Alrighty, a couple hours later here, specifically like 7 or 8 hours later, so the epoxy has had time to cure. I've got some pieces here so I can share with you guys my results of the thing. Here's the piece that it's just a single layer of 7.5 ounce equivalent fabric. This particular fabric I picked up at Walmart last year, but it's the same basic build as my 7.5 ounce stuff. It's pretty dang similar. So I just one single sheet here with as little epoxy as I could, so it's incredibly light. But as far as strength is concerned, just to give you a rough idea, I don't have any way of clamping this down. Let's see. I didn't plan out this video beforehand. Baloney. Let's see if I can show it to you here if I hold it here. So I've got one piece over the top, there's nothing on the bottom. You can see, if I hold it here, it flexes, but it's the foam that's compressing. If I flip it over and I put it in tension, it stretches the foam. So when I put a second layer on the back side, it'll be exponentially stronger and only marginally heavier. It's still incredibly strong. Cool tidbit about epoxy versus like how the resin, the epoxy fits into play with the fibers. It's actually not the epoxy itself that does the hard work. This fiber all does the work. The epoxy is essentially a catalyst. The epoxy bonds the individual fibers together. So the fibers do all the work. You can see if I go over here, it's still very flexible with the epoxied fibers. And if we go over to, like for example, this demo here, this is just a little piece of foam, and I just put epoxy on it just to see how it would behave, and it's still, even with this cured epoxy resin on it, still very flexible, despite being entirely coated on the top with epoxy. You can, I guess you can't really see it, but it's shiny, it's hard, but it still breaks pretty easily, and it's still very flexible, even with the epoxy. The epoxy itself doesn't do much. It's when you put it, when it has something to bond together, like this brush, that's when it gets hard. Or here's another great example of, here's just another little test piece. This is stranded mat, not woven like the other stuff, but still approximately the same weight. It soaks a little more epoxy, but I just threw this together with the last remaining bit, and you can see here that this piece that's been epoxied, you can see that it's actually quite flexible. Bends. It's not easy to do. I have to apply considerable amount of force there, and it's not breaking. It's actually peeling the foam apart, or peeling off the foam. You can see where it bonded to the foam, it's peeling the layer of foam off. But it's ridiculously hard. It's super strong. Just to kind of give you a point of reference here, 3-pound sledgehammer. I'm just gonna let it fall. No damage. And if we hit it as hard as if we hit it freaking ridiculously hard, you can see the damage it did there. Under the foam. or maybe you can't feel that on the surface, but that's like on the underside of it all. And it kind of bent the piece a little bit, but especially with the foam behind it, it doesn't break. If I had my 22, I'd shoot it and show you if it's bulletproof or not. But I mean, I've only got one layer on, so it's, I mean, the foam's taking some of the force, yes, but it's still, if I put the fiberglass in the back like there is right here, it still wouldn't change anything. It'd be even stronger then. So it's a little demo of what fiberglass does. Now there's a huge difference between, this is epoxy resin. Epoxy. This isn't polyester resin, which is like that. Great stuff, has its purposes, but if you use, especially with the foam, if you use polyester resin, I don't know if you can see this too well, but it actually ate away. You can see it really easily in person. But if you see it ate away at the foam instead of just bonding to it, you can see it really well right here. It just ate away the foam. It reacts. It's the polyester resin reacts with the polystyrene in a similar way that acetone does, just not quite as violent reaction. So you can't use polyester resin with foam, or with polyester foam. It doesn't work. Epoxy resin, on the other hand, is about 3 times stronger than polyester resin, and it doesn't hurt the foam at all, as you can see. Super easy to work with. But yeah, another thing that wasn't explained to me while I was doing my research on epoxy and whatnot, but so 2 things. One thing I don't know, and if you know, I would love an explanation on. But one thing that I never knew when we're looking at this stuff, like the pot life, that's how long it can stay in like a container. I mix it up in this cup. How long it can stay in the cup before it gets hard. So this one's medium speed, 20 to 25 minutes pot life. What I didn't understand until working with it is why, when the larger the batch you mix, the larger the batch is, the quicker it cures in the pot. So if a large batch will cure really quickly, and a small batch will take longer to cure. Another thing with resins, especially with epoxy resin, is it's a chemical reaction. So the hotter it is, the quicker it cures. So if you're 90 degrees out, your resin will cure very quickly. If you're 20 degrees out, your resin will never ever freaking cure. Combining that with what happens is it's an exothermic reaction. So when I mixed up this batch, I mixed up 4 ounces there. This was hot. It was very warm to the touch. It wasn't uncomfortably warm, so it was like about 100 degrees or so Fahrenheit. But the larger the pot, so the larger your batch, if you mix up, say, a gallon, it's going to build up a lot of heat in the middle. It's going to cure a lot quicker. That's something that was never explained to me in there. All I knew is the larger the pot was, the quicker it cured. And so when you spread it out, it takes like 8 hours or so to cure. It was never explained to me that it's because it's an exothermic reaction and generates a lot of heat. I found that out when I made this piece, and I was like, wow, this is really warm. So that's something that now hopefully you know. What I don't understand is with these particular hardeners, this is a 3-to-1 mix. The faster one is a 4-to-1 mix, and the slowest is a 1-to-1 mix. I don't particularly understand why adding more hardener, even if it's a different kind of hardener, but why more hardener equals less cure time. That's what I didn't understand. So if anybody has any insight on that, my few watchers and whatever, that would be much appreciated. But in the meantime, that's my spiel on epoxy resin. That's my Stage 1 results. Stage 2 will be when the back half of this scrap piece is glassed, and you'll see how fucking strong and light and ridiculously badass this shit is. So until then, this is Stir the Dur signing out there with Shout out to US Acoustics.